Hi everyone, myself is Shaikukar, very warm welcome to all. And this is day two of Foundation AI series. And in this day, we're talking about AI infrastructure and you can say uh, a little bit about AI life cycle. So overall agenda for today is we are going to discuss about what is AI infrastructure that we need to making such robust AI infrastructure and how to make what is the life cycle of AI. So maintaining such as a life cycle for AI. So it is important to understand. And as you know, our last agenda is all about real world example. So this is three agenda, and I will try to explain you this all these three agenda in such a way that you will understand much clearly. And if this particular video is going to productive for you and you'll learn something from there, then it's my pleasure. So let's get started. Hey, let's come to agenda number one. And in this agenda number one, we are going to discuss about what is how to make AI infrastructure, like how to make robust AI infrastructure. So that is an important part, and we need to understand it much clearly because of that. When you're looking toward to making a your own system, like you should to know about what kind of hardware that we need, what kind of software that we need. So basically, this is a very foundation part. So I will try to discuss with you. So let's get start. And when we're looking toward the AI infrastructure, when there are two main part, as you know, because of that, the first part is power, and second part is your orchestration. So if you don't know what is orchestration, I will explain you. Uh, Orchestration refer to the management. So how can you manage this particular power? First is power requirement for power, and second part is your orchestration. So this two thing is important while you making a on AI infrastructure. So while you developing on AI infrastructure, like the first hardware, like GPU and memory. So this is two things is very necessary. Because of that, when you're looking towards like hardware, so hardware is all about power, to giving a computational power to handling a complex calculation. Hardware is all about just a hold per minute. So hardware is all about computational power. So it gives a computational power, like handling a complex calculation. And GPU is all about GPU and TPU help us to handle a complex calculation. Okay, and if you're talking about memory, so in AI, the memory play a very important role to storing a data. You can understand much clearly. While you're training a model, your model learn lots of things, and that's learning. You need to keep particular model learning, particular model knowledge in such a storage. So long-term storage, we need to store this particular thing in a long-term storage. So we need to keep this particular memory as a long-term storage, and that's the memory is important for storage the knowledge, storing the knowledge of the particular model when you train. Okay, so that's the hardware, like especially GPU and TPU is important. Like GPU, you can especially now NVIDIA H100 GPU is too much famous right now for model training, and TPU like Google TPU 8 series is too much famous right now for this particular training a model like Tensor Processing Unit. This is called, and that's I understand about the TPU and GPU, and that's the basic role of GPU and TPU as a handling a complex calculation. You need to strong GPU and TPU to running an AI model and deploying an AI model. Okay, okay. So one more thing, like we're talking about software. Software is a very important part while looking toward like framework and orchestration and model architecture and data pipeline. So in software is all about managing. So you handle an training itself again, and you need to adjust this but managing hardware and software. So orchestration particular software help us to manage you about manage your own your power, like handling calculation. So it give a direction to your power to use to learning a model. So so specific when we talking about software have a four main component that I will discuss. We discuss lots of about it, but I I written the four basic point that I mentioned about software that we should to know about, like framework. So framework in short, if I want to define this framework, framework is all about, you can say, inbuilt code. So it is inbuilt code. Like for example, you can understand like when you write 100 lines of the code for training an algorithm. Instead of writing 100 lines of the code, can you write a 10 lines of the code in just replacing by and getting the same output? So inbuilt code, like already written code, like when you're making on model, like AI model, you need a huge amount of mathematical equation, calculus, and huge, you can say huge lines of the code. So framework help us to give you inbuilt code. Just you need to mention and adjust little bit around this particular code, and you get an output. Okay. So one of the famous framework that I think like nowadays, like TensorFlow, and PyTorch and JAX. This three framework is now famous, and you should to know about, because of that while you're making on model, like right now this model is rapidly very used. Okay, and okay, so let's come to the point of orchestration. Orchestration is all about, you can say, managing of the software. So when you manage a software, like for example, you need to manage a software like where all the resources. For example, where when you're making our AI infrastructure, okay, and when you're making on model, you need to train a model, you need to scale a model, and you need to deploy a model, and you need to make a, such a reliable model, so in such way like they can handle all errors. Okay, so this orchestration manage itself. So few inbuilt software are open source now, right? Present right now is open source, and they can actually reduce, and they make reliable to any particular framework. Okay, for example, Kubernetes. So Kubernetes is the best example. Kubernetes is the best example, you can say, orchestration tool right now, and lots of people using Kubernetes for training on model. In fact, that's the very important part. And okay, so let's come to the model architecture. So when you're looking toward a model architecture, I think like model architecture is depend upon what kind of problem that you're solving. So there are lots of model architecture that I think like CNN and RNN, and you can say GPT transformer and GPT and transformer. Okay, so CNN, RNN, and GPT transformer. So why this particular, there's three model architecture right now available, and you should to know about it while you making on particular infrastructure. And for example, CNN is specially built, and this is a kinds of model, okay, algorithm, okay, neural network framework. So this is neural network framework. It is specially designed for analyzing and training particular thing as images. If you have an image data and you want to train, such as you make a image generation model, okay, and you need to choose the CNN system. The CNN refer to convolutional neural network, and RNN refer to recurrent neural network. So that deal with only for sequential data, and you can say time series data. And GPT refer to GPT refer to, you can say, GPT and transformer, like generative pre-trained model, and GPT, you can say chat GPT also. But in fact, that's the important point. Like transformer, transformer is all about algorithm designed for such as reading such sequence of the sentence, sequence of the word to breaking down. So it is all about language model. So when you're making language model to understand human language, so you can use this particular transformer. Okay, and when you're looking toward the RNN, so RNN is all about like train for the sequential data. It's all about like time series data, like weather app. So its particular algorithm need to update according to time. So we choose this RNN, recurrent neural network. So this is a type of neural network, but you can say, and we need to choose this neural network according to the particular problem what going to solve. So when you're going to solve the particular problem, like CNN, CNN is used for when you're solving a image problem. So you can use CNN neural network, and RNN when you use such a recurrent neural network, and you can say GPT and transformer is actually used by your basically when you're training a particular model as a language. So that's all about for today. And you can say one of the last topic is like data pipeline. So data pipeline is important, like a strong data foundation you need. Uh, I will give an example for this. Like you have a huge charts of data, okay, but this data create a such as meaningful insight. So is this particular data have an actual meaning that you can say this particular data is like, useful? So hope so. I will try to explain you this particular topic in such a way and clearly. And see you soon. And let's come to agenda number two. Hey, let's come to the agenda number two. And in this agenda, we're talking about like what is AI life cycle. So life cycle, we can understand the life cycle better in easiest way. And I will try to explain you the life cycle in such a way like you can understand. But Okay, why this particular topic is necessary to understand? Because of that, in my language, if I'm looking towards this, how this particular topic is necessary to understand about the life cycle, AI life cycle. So when you're making your own model, like you should to know focus on like a full life journey, you can say full process and full cycle of the artificial intelligence, the maintaining, like deploying, and all this stuff. So how can you do all this stuff? And I will try to explain you. So let's come. So first of all, let's come to the like AI life cycle. So the first one is the data. So data is very important when you're looking toward the making or model. Your strong data pipeline is very important. Okay, you collect the data. Okay, and then after second part is choosing a right model. So right model, choosing a right framework. You can say there will be lots of model. You can say model important because of that. Model architecture is really necessary when you, for example, according to depend upon your data. Like if you have a numerical data, then you can choose best option like you can say GPT, and transformer is the best option for that. And if you have such an image data, then you can choose CNN, a convolutional neural network. And if you have like text data, you can choose RNN, and sequential data and time series data, you can choose RNN also. So this model architecture, you need to choose it because of that. Like when you're training a model, every model have an on model. Like every problem, every data have a designed and a specific model. Okay, when you're dealing with images and text, all this stuff, then I think like the best model is GPT and transformer. Okay, so when you have a data, when you choose the right model, then the second step, a third step is monitoring. So you are going to develop the deploy this particular model and go to monitor your particular application. Okay, so for example, you should to know about monitoring. Like how can you monitor this particular data, like your particular model. Like now suppose the chat GPT is the best example, and in this chat GPT, you are going to just particular company monitor this particular model in such way like changing and learning, helping the learning progress, looking toward the reliable sources and source code and changing all this stuff to continuously improve. Okay, so that's the monitoring part. And one of the last part is iteration. So iteration is all about, you can say, giving a feedback to model to understand and the learning process. Okay, so that's how the particular model is work. And I think like for understanding model, iteration is all about feedback. So giving a feedback to the model to understand and learn much better. So that's all about, you can say, AI life cycle. And this is a very important to know because of that. When you making on model and just you're going to uh, just launch for your public uses, then you should to know about that what kind of condition that we need to follow. Like monitoring is important because of that. Your model start continuously learning, and just you need to monitor about because of that. Without monitoring, model get and generate some error, and reliable, scalable, all this stuff is very important. So that's why the important to understand AI lifecycle. And you can take the best example as the weather app. So weather app is the best application of on AI lifecycle you can understand. And for example, if I want to explain you about weather app, so weather app is all about, you can say, this having a huge amounts of data, and after this data they are choose and model. Okay, you can choose RNN because of RNN continuously time series data, which is based on time series data. So RNN is basically trained on weather app, and then after the model you can going to develop and deploy this particular model. Then after monitor and then giving a feedback and okay, to improving this particular accurate model for better prediction of weather. So that's all about for AI lifecycle, and I will try to explain this my best. Let's come to the agenda number three. Hey, let's come to the real world. This is agenda three, and let's come to real world example. And in this real world example, just we are talking about like how this particular hardware and software and this important in such as real world to making us such as AI to powerful. So let's come. And I think like the best example is your self-driving car. And when you're talking about the self-driving car is just has lots of computational power inside it, and they can not access like they take a decision, quick decision we need, and to quick action for protecting the user safety and particular driver safety. It's all about self-driving car is the best example for it. And let's come to understand. Okay, so self-driving car is all about like data, process, and action. So you can say it is just self-driving car take data from this radar information, like radar information, and radar, because of it long distance, it ultra radar is the best option for this, and the camera as the best example, and one of the, you can say, sensor data like noise sensor, anything like all this stuff. They take the data from this particular thing, and they make a strong data pipeline. Okay, and instead of taking this data from this outside of road and taking data from there, and just process it and take an action. So hardware like GPU, memory, and software, this all this stuff are important in this particular self-driving car. Like, I will explain you like how this particular is important. Hardware is important, like taking data and we need to process it, and we need to handle a complex calculation right now, and we need to strong GPU in this particular self-driving car, and memory to storing a particular data for future action. Like if this particular incident happened, and then we learn something from there, and the this particular action was stored in particular GPU, memory, and all this stuff. Okay, so that's why important. Okay, so this particular data is important, like, and the software inside it, self-driving car, help us to reduce, to learn, model, understand, and help us to learn, model, and make a command over there. So that's important. Okay, so when we're talking about self-driving car, it's the best important, but when we're looking toward it, and this is important, more important if you're looking toward it. So, and self-driving car is the best example, but you taken a lots of example. Weather app is also similar like this, and when we where you find like AI, so it is all about hardware and software. So hardware is all about power, and software is all about control, to giving a power, to using this power to getting some output. So software is all about management, and you can say hardware is all about the power. Okay, so hardware take a command for complex calculation. It handle the complex calculation. Okay, so that's all about basic tied together to making such a huge and you can say strong AI model or anything else. So you can look lots of example like ChatGPT, as inside it, like you look the behind of this particular ChatGPT, the massive system running behind the scene. You can say uh, first, for example, lot you can take a lots of example, but in fact, my example is like ChatGPT use strong GPU. Like NVIDIA is a partner of the particular OpenAI. Because of that, hardware support, and that's enough. So hardware is important and software is also important. So that's fine. That's fine for today, and I will discuss with a particular topic. And uh, let's get ready for day four. And so, thanks for watching. And if this particular video is going to productive for you, and if you learn something from there, then it's my pleasure. So let's get started.